Hello, everyone, and welcome back. Um, to start off today, I want to give you an overview of where we are in the course. And so on our course website in that Getting Started box, I've posted a course map that looks like this. And basically, we've done the first two units, and we're about to start on Unit 3, which is called hypothesis testing. And the first lesson or topic in Unit 3 is sampling distributions, and that's what we're going to talk about today. Now, today marks a shift. We've kind of been dealing with, I'd say, normal, everyday, ordinary statistics like mean and standard deviation and median and mode and range, things that you're probably familiar with or you were familiar with at one point or another. And now we're going to kind of step into an alternate universe. In the past few weeks, we've been looking at individuals and groups of individuals. And now we're going to step into the alternate statistical universe where we're looking at groups of groups. Okay, so yeah, I'm really excited to introduce this to you. But don't worry, if some of it doesn't make sense right now, that's okay, because we're going to be coming back to these concepts again and again throughout the next several weeks. Okay, sampling distributions. Before we were looking at the distributions of individuals, whether they were individual heights, individual lengths of pregnancies, individual birth years, the math scores of individual states, whatever it was, we were looking at individuals. Now we're looking at the distribution of samples. Okay, so speaking of heights, I have taken all of your heights in inches, and I've printed them out on little pieces of paper and put them here on the table. Okay, so let's say that our class is the population, right? And so we already know, let me see if you can see this. Yes. Okay, so we're talking about sampling distributions. And for our population, that's our class, we know that there are 23 people in our class. We know that the mean of our height in inches is 68.4. So that's the population mean is 68.4. The population standard deviation is 3.47. Okay, so that's our population. Next, let's take some samples from this population. So we're going to draw randomly going to grab 3 heights. Okay, this is my first sample. Okay, I'm going to assume that's 66 and not 99. Okay, so I drew 3 heights, right? And so this is my first sample, x sub 1, my first sample. I want to find the average, and my sample size is 3. Okay, so I get my trusty calculator here, and I have 71 plus 66 plus 68 divided by 3 equals 68.3. Okay, so for our first sample, let me pull you a little closer here. Our first sample from our population, we got a mean of 68.3. Okay? Now that's not too far off. This blue is kind of hard to see, isn't it? Let me trace over in black. So our mu was 68.4 and our sigma 3.47. So 68.4 was our population mean. The mean of our sample is not that far off. It's 68.3. There is a difference between the mean of our sample and the mean of our population. And that difference is the sampling error. Okay? And that is 0.1. Okay? Just the difference between the, and I'm going to put it as negative 0.1. The difference between our sample mean and our population mean. Okay, let's do another one. Mixing them up, drawing 3. Okay, and this time I got 69, 69, and 72. Okay, so 69 plus 69 plus 72 divided by 3. This time for the second sample, I got a mean of 70. Okay? And now if I want to see what the sampling error is, I'll do 70 minus 68.4 equals 1.6. And this is positive. Got that? All right. And I'm putting these back, the 3 that I already drew in, and mixing them up and drawing 3 more at random. This time I got 67, 67, and 72. 67 plus 67 plus 72 equals 206 divided by 3 equals 68.7. So now let's do that minus, let's find the error. So the distance, the error, minus 68.4 equals positive 0.27. Okay? So far I've drawn 3 samples. There's X bar 1, X bar 2, X bar 3. Okay? Now let's do one more. Mixing them up, drawing my random sample of 3 heights from this population of heights. This time I got the same thing, 67, 67, and 72. Ha-ha! Wonder what the chances are of that. Plus, yeah, just making sure I get the same answer. I sure do get the same answer. Okay. 68.7, and so we know the error is plus 0.27. Okay. So now, we know we can draw samples of some sample size. We see that the samples we drew, none of the samples had the exact same mean as the mean of our entire population. They varied from the mean being 1.6 inches higher than the mean of our population to being 0.1 inch lower than the mean of our population. So these are our samples. These are the means of our samples. Now, just like we can graph individuals and make a frequency chart, we can graph these means. And so let me slide you over here. And y'all will have to let me know how these videos are coming out for you on your devices. Okay, so on the x-axis, we're going to graph sample means. On the y-axis, this is going to be a frequency chart, so the number of sample means that are in a particular spot. It looks like these vary from 68.3 to 70. So let me do 68.5, 60. Let me do this sideways. 68.5, 69. 69.5, 70. Okay. So our mean of 68.3 would be somewhere around here, and we had one mean of 68.3. So let me make a little box right there. Okay, and we had one mean of 70. So let me make a little, 70 will be in the center. I'll go up to 1, make a little rectangle right there. Okay, so now we've graphed 2 of the means. Let's graph the next 2. And we had a 68.7, which would be somewhere over here. One mean of 68.7, and another mean of 68.7. Okay, so we could graph the distribution of the heights in our class, right? That would be graphing these individual values. Here we've done something different. We've graphed the distribution of the sample. We've graphed the means, okay, of the samples that we drew. All right? Okay, so I did this by hand, but in our on your slides, there are pictures from a simulation where you can do this kind of exercise using a Java applet. So I'm going to sign off for now and go get my slides, and we'll start talking about that. Okay, so sampling distribution. All right? See you soon.